I'm Steve, and on this channel, I tell you about fascinating things related to our world and beyond. Today, we'll find out what if you shrunk to the size of a molecule. Let's go! Imagine waking up one morning and realizing you've shrunk. Not just a little, not just fun-sized candy bar small, but to the size of a molecule. One moment your cereal is a comforting breakfast, and the next, those crunchy flakes are as massive as mountains, with sugar crystals glinting like glaciers in the morning sun. Your kitchen counter? Suddenly an endless, jagged landscape of plastic and metal canyons stretching as far as your microscopic eyes can see. And that coffee mug? Oh, the coffee mug. It's basically a steaming lake with waves that could drown a city in seconds. At this size, the world we take for granted becomes incomprehensibly vast. Air molecules that were once invisible to you now zip by like speeding cars on a highway, colliding, bouncing, and forming invisible walls that shape the very air you try to navigate. Gravity still works, but it feels different, weak, almost negligible. Instead, your every movement is dominated by forces that usually hide in the background. Van der Waals forces tug at your atoms like tiny clingy hands, and electromagnetic interactions make it feel like you're constantly swimming through a chaotic sea of invisible magnets. Now, imagine you try to take a step. You push against what feels like nothing, but the world responds unpredictably. The surface of your kitchen counter is not smooth at this scale. It's a jagged jungle of polymers, bumps, and ridges. You might slide off a single cellulose fiber and tumble down what feels like a cliff hundreds of meters high, though in reality, it's smaller than the width of a human hair. And that's before you even consider water. One drop of spilled juice transforms into a tsunami of H2O molecules, a storm so powerful that trying to swim through it is like wrestling a cloud made of jelly. Temperature, too, becomes a personal roller coaster. Molecules jiggle, vibrate, and collide in ways you've never noticed before. You might feel like you're standing in a sauna as surrounding particles dance wildly, or like you're freezing solid when molecular motion slows just a tiny bit. And the funny thing? You can actually see chemical reactions happening around you. Baking soda fizzing, sugar dissolving, soap bubbles forming. All of it becomes a microscopic ballet of molecules bumping, bending, and bonding in ways that are as beautiful as they are terrifying. Food? Forget about it. Salt grains are mountains. A drop of honey is a sticky swamp. Even oxygen molecules seem like relentless, invisible predators, darting past at impossible speeds, nudging you around like a pinball in an atomic arcade. But it's not all bad. You might ride a gust of air like a roller coaster, surfy molecules with the grace of a microscopic windsurfer. Every breath of air becomes an adventure in dodging invisible highways of nitrogen and oxygen. And then there's the ultimate cosmic joke. Even at this minuscule scale, danger lurks in the smallest forms. Dust motes are like giant boulders. A stray static charge can fling you across the room. And a simple human sneeze is a catastrophic hurricane, capable of scattering you across continents of tabletop terrain. You begin to realize that the rules of physics aren't gone, they're just hyperactive. Brownian motion isn't some abstract concept anymore. It's your daily commute. Entropy isn't a term in a textbook. It's the chaotic, unpredictable whirlwind you must navigate just to stay in one place. But shrinking to the size of a molecule also brings revelations. You see the hidden life of matter, the way water molecules cling together to form tiny dynamic lattices, how polymers twist and fold like massive, unseen ropes, how electrons flicker and spin, shaping everything you thought was solid and stable. And as overwhelming as it is, there's a strange beauty in realizing that the world you thought you knew, the world of breakfast cereal, coffee mugs, and countertops, is just a tiny, shallow layer atop an endless universe of motion, vibration, and life at the molecular level. By the end of your microscopic adventure, you'll have gained a new perspective. you'll understand why water behaves the way it does, why surfaces aren't really smooth, and why the forces that hold the universe together are invisible yet incredibly real. You might even laugh, realizing that being small doesn't make you powerless, it just gives you a front row seat to the wild, chaotic, and hilarious molecular theater that underpins every moment of your normal-sized life. And when, finally, you return to your regular human scale, you'll never look at a drop of coffee or a sugar crystal the same way again.